Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be doing things a little differently, and instead of solving another daily coding problem, we're going to be solving a Leetcode problem. A few weeks back I sort of came across this comment from someone who will remain nameless, who was telling me to implement Leetcode problem 14, but the twist that that person added was that they wanted this thing to be solved using trace. Now, I can see that happening in an interview because interviewers are usually notorious for giving these, limitations to a person, and that's just to test out how good your data structure knowledge is. Again, if you've not sort of gone through this previous video, which is problem number 11, in which we implement an autocomplete, you'll not be able to understand what we're doing. So I'd sort of urge you to pause this video, go back to that video. The link should be in the description below, and then you can come back to this video because we are going to be using the same code. So let's go to problem number 14 and see what it really is. So if you see over here, the name of the problem is longest common prefix. It's an easy problem and it's pretty simplistic. You have to write a function to find the longest common prefix string amongst an array of strings. So you've been given an input over here. You have flower, flow, and flight, and you know that FL is the common prefix amongst all these guys. So that's what you need to output. And if you have dog, views, car, and car, then none of them have any common prefix. Prefix is the starting part of any string. So since none of them have any common prefixes, then the output is an empty string. And that's pretty simplistic. You can solve this problem by doing a simple for loop, and that should work. But if an interviewer sort of suggests that, hey, I need to make sure that you use a data structure over here for faster computations, or if an interviewer sort of poses a problem like, hey, we just want common prefixes, but the common prefix could be only for 2 words instead of 3, instead of all of them. In that way, you would sort of have to use some sort of approach. And trays are perfect for that. Whenever you come across something like this, your entire ideology should be how can I solve this in the most simplest way possible. But if the interviewer is sort of just pushing you to use a tray, then you don't have any choice. You'll have to use it. I'm going to go back to one of my previous solutions, and this is what I was sort of talking about. We've already done this, so I'm just going to copy this code and just paste it inside. This is going to work like a class, so it should be pretty straightforward. We don't need some of the functions, so we can remove search and starts with and all that jazz. Um, and we just need insert for now. We'll come up with one more function which can be used for our purpose only. Cool. So this is pretty straightforward, and let's just start with it. So again, we always start with our base conditions. The base conditions would be, whoops, hold on. So the base conditions would be, hey, if there are no strings, then you return an empty string. And one other base condition that you can have is that, hey, if the length of the strings which are being passed over here as a parameter is equal to 1, then just return the first word or first string, whatever. Pretty straightforward. There's not that much complexity in these base conditions. Um, and now comes the entire essence of how you would want to use trays in this instance. So if you've already gone through the video, you know that we're sort of recursively updating the words inside that value one by one inside our tree, which is basically a dictionary structure. And assuming that this is going to work fine, and we know for a fact that this works fine, we're going to be pushing all the values inside all the strings one by one, or let's call them words because strings is going to be confusing. So all the words one by one inside the tree. So once we do that, we'll have an entire tree data structure, and then we can sort of move forward with it. So pretty simplistic. Let's just do a quick for loop. Let's do a word in strs, and we need to define a tree object. So let's just do that. Let's just instantiate it. Um, yeah, and just do a simple insert. I think that should work. So now if we do a quick print, you would be able to see that actually this would not work because we need to do tray of tray. Um, so you would essentially be able to see whether that data structure is sort of working in accordance to how we expect it to work. So you can see you have F as a dictionary, which has another dictionary, which is L, then O, then so on and so forth. And basically, the breaking point should be pushed inside our tray class. And the breaking point would be, hey, if the length of the keys that we have so far is greater than 1, that would mean that there are more multiple elements in this case. So that's when we would break things off. And I hope that sort of makes sense because it's pretty simplistic. You just have to like look for that particular thing. Cool. So let's just quickly create another method and let's just call it check till, whoops, check till split. We're gonna pass in the self and we don't need to pass in anything else. And the expectation would be that it returns a count. A counter variable can be used so that we can use that to return the expected value. So we're going to maintain a simple count, which is just going to keep on counting the values where the common prefixes are there. And again, the common prefixes would be there when the length of the keys inside the inside the tree at that particular level is only 1. So the way we traversed it before is what we're going to be using as well. So we're going to do self.tray is equal to tray. So just like we have something over here. And when we do a while loop, we can say while length of tray is equal to 1. We keep on iterating the value of count. Pretty simplistic. And this is just so that you keep on updating and you keep on going down the levels of a tray data structure so that you have, or you only have one key, and that would be the longest common prefix, right? Pretty straightforward. And now all you need to do is inside the tray, you need to update it. And we know for a fact that this particular tray object will, at least for this particular level, will have at least one key. So we can get that key and we can use a cool little method which I actually know about, which is just using a next and putting an okay, so making the object an iterable and then calling a next on it. So that should pass in the next key. Pretty straightforward, and then we can update our tray to point to that key, and that should do it. You can also, like, if you want, you could just use something as simple as tray.keys and get the first one. It's the same thing. This is just like a quick Python know-how, which if you know it, it's pretty cool. It sort of impresses the interviewer as well. And yeah, basically you need to return the count eventually once the loop breaks off. So the loop will break off whenever it finds things which are more than um, 2. So you can have a look at it over here when you have flower, flow, flight. F is going to be just one substring, so you go to the next for loop, next loop. Then L, then you'll traverse the values again. Then when you get O, you will see that O and I are actually the two values inside element L, and that's when you want to break out. So that's how you would probably split it. Pretty simplistic. And now all you need to do is you just need to return the because the expected attribute is not the count at which it breaks off, but rather the substring, the prefix. Um, so let's quickly get that. Let's get let's sort of push this whatever function that we've done inside another value. Let's call it split. Let's call tree and do check to split, which should return an integer. And yeah, I think we can just call a simple str's 0. That would just be the first word. You can pick up whichever word that you want because the split should ideally work on any one of them. Um, and just return the substring from that split. Let's quickly run this code. Hopefully this should run fine. And yeah, it does. So awesome. We can go ahead and submit the solution. And you can actually just, even if you want, you can do a more optimal solution than this. There are multiple ways of going about it. But again, like if the interviewer sort of asks you to do a tree solution, you're just restricted to that. You don't have any other options. So you're going to be, you'll have to do it. So it's always good to have like knowledge of your data structures in that sense. But the smart way is just that once you're done with those traversals, you just need to know how you want to iterate through all those values. We've already talked about the iterations in the previous video as well, where when we search for the value, we keep on updating the key, and I think it's better explained over there. But we're following the same concept, so if you're familiar with that, this thing should be pretty easy as well. All right, cool. So that's it for today's video. I just want to thank you all for watching this video. And if you did like this video, do give a like and do subscribe to this channel. We are discussion over here. And if you've already subscribed, you're awesome. We all know it. And have a nice day. Thank you.